Well, thank you very much for coming. And so I accidentally became interested in demography, not least because the data for demography go back a very, very long way, and they tend to be quite consistent. The further you get away from matters of life and death and counts of life and death, the more unreliable the statistics tend to become. It becomes easier to argue, well, it could be showing this or it could be showing that. But if you actually have records of people who have died, that's very, very reliable. People tend to be quite consistent about that. However, I was very interested in applying the same method for visualizing demographic data to conviction data, and this is following from using Ben's data. So I really need to thank Ben a lot for him doing the hard work of actually getting all of the numbers, and I just kind of process it through R and make pretty graphs and that sort of thing. These are of prevalence, and these are from exactly the same data source, subdivided by age and by year, and separated for males and females. Basic structure. I'm going to talk about a particular type of data visualization that is very sort of information rich, and that's not necessarily a good thing. It's not like a kind of Guardian infographic where you can kind of look at it for 3 seconds and then you get everything out of it. It's a particular type of visualization that contains a lot of information. It's about unpacking it, and it takes a little bit of time to get used to it, but it rewards you. So I'm going to talk about the basis of contour maps and Lexus surfaces, which is the type of visualization, or the type of data visualization principle that I'm using and applying. I'm going to talk a little bit about the data, then it's going to be about the visualizations, and it's going to be exactly the same data presented in a number of different ways. So shaded contour maps is something that I accidentally reinvented and then got published and then got told afterwards it had been done in the 1980s. So there you go. The peer reviewers did not know, and I did not know. So that's good. I'm assuming the fact that it's been reinvented means that it's a good thing, and it should have been. It's like co-evolution of some trait. It's a really good thing, and it deserves to be reinvented. But hopefully they won't forget me. Let's see. So it's a high information density method of visualizing data arranged into Lexus surfaces, which raises the question, what are Lexus surfaces? The basic idea is, if you have a time series graph, you're applying the metaphor of time is space. So left is older years, right is newer years, and then you've got an amount that goes up and down at different points throughout that time period. This is using one axis as year and the other axis as age. So you've used up both axes, and then at each combination of the X and Y value, each combination of age and year, you've got a value. So it's a rearranging it in that sort of way. And the good thing about doing this is you can then get thousands or tens of thousands of numbers in a single Lexus surface that's marked by... so the Lexus surface is a surface of age time, not of latitude, longitude, but of age time. If you do this for mortality rate, so this is Italy, you've got a contour map representation of it. So the idea with contours, just as with orienteering, each contour represents a fixed height. But you could also take the same data and use some kind of 3D visualization. So this is 0-year-olds up to 80-year-olds, this axis. And then it's about 1860 to 2010, that axis. And you can see something happened around about 1914 to 1918, and then something else happened around about 1939 to 45. So that, not a lot of people know that, but you can see. For instance, that if you're representing that visually, you've got this. You've got the mortality rates associated with being, in this case, 18 to 30-year-old males in 1914 to 1918. And you can see in the case of Italy, it's much higher for the First World War than for the Second World War. So this corresponds with this corresponds with this. And you also see here, this is the reduction in infant mortality. So this is the basic principle that I'm applying to Scottish crime data and its prevalence rates separated by male and female from 1989 to 2012. What you can get from this is you get group effects, as I call it, which is basically gender. So if you're going to be forced to stereotype and figure out of two people who's more likely to be a convict of some sort, or to have been convicted, or to be convicted this year, then you've got group effect, which is basically gender. You've got age effects, so what is explained by knowing people's age only. You've got period effects, what is explained, what is understood by knowing the year in which records were observed, and there's cohort effects. So what is it that a particular group of people born a particular year carry with them in terms of a conviction rate that's not explained by those other factors? So the data is exactly as Ben has described. From 1989 to 2012 for Scotland. I've looked at ages 16 to 60, because beyond that, as you might expect, given the age crime curve, the numbers just become too small. What I've got here is a 3D printed version of males and females side by side. I've also got it here. So on the same scale, you can really see the difference between males and females. So this is 1989 to 2012, 1989 to 2012, 16 to 60, and you just see the difference there. But one of the advantages of looking at it on a contour plot is you don't just see it, you can actually kind of quantify it. So there I've got the again the males here and females here, and again these to the same scale. Now this is the information visualization itself, which, as I said, is quite information rich. It's quite data rich. So I think quite a lot of people's first reactions on seeing something like that is, what the hell is it? But let's orientate ourselves. So we've got 16, 20, 30, 40, 30, 40, 50 and 60. On both cases, this is females, this is males. I was talking about contour maps. So the idea with contours, if you're representing a hill with contours, then you'll have lots of concentric circles. Those are the peaks. You're seeing peaks here. So this is 1990 to 1995, so about 1993 for females and also for males. Something similar. Yeah, so peaks around about, it's easier to see here. Peaks there, which is about 1992, 93, then there, then there, then there. which, given the visualization itself, you can see kind of corresponds to this. So peak there, 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 and there, and you see each peak is lower than the previous one. What I'm going to do now is look at each side on its own. So we've got females on the left, males on the right. So the female map, the good thing with the contour maps is each of these contours is labelled, so you can work out what the conviction rate is that contour is associated with. So it goes up to slightly more than 0.012, so about a 1% prevalence of conviction at particular, at peak ages, at the peak age of female conviction. This is the males. And you see it's a lot darker, so darkness, the darker the shade, the greater the amount of conviction. It actually, you can't make it out, but it actually goes to above 0.10, so it's about 10 times as high. Both males and females, their conviction rates peak at about the same level, at about the same age, but they peak around 10 times as high for males compared with females. And one of the good things, that 0.012 I talked about before, you can work out which, what age you have to be if you're male to have the same rate of criminality, at least measured this way, as compared with peak females. And you actually have to be a middle-aged man in order to have, the conviction rates of a Vicky Pollard or so on. So whatever the more recent version is. Yes, a Scottish version of Vicky Pollard. So one thing I'm doing is when I'm talking about the age period and cohort effects, it's basically like taking sections. So an age effect is like taking sections vertically, one piece at a time. So that would be the age effect. That would be the period or year effect. It would be taking sections this way. And if you find 1 year by 1 year and you take these diagonal lines, those are the cohort effects. So what I'm going to do is present each of those separately.
So what you see here is an alternative way of looking at the same data. Now what we've got is a series of graphs, one for each year, showing the conviction rate on the y-axis and the age on the horizontal axis. And it's plotting this relationship for each year for males and for females separately. So this, in terms of the contour map, is equivalent of, for both the male and the female Lexus surface, taking a series of vertical slices, a series of vertical sections through it. Now this is what you would see if you did that and then turned each of these sections on their side and then kind of looked at them at their face. Now what this reveals is the very well-known age crime curve. What we've got here is another way of looking at and slicing through the data. What we've got is the age-specific mortality conviction rates. So for each year from 1918 to 2012, given your age and your gender, what's the conviction rate? Now you can see some quite interesting pattern here in that this mortality, this conviction rate reduction hasn't occurred to the same extent in all age groups. It's occurred amongst those age groups that historically had the greatest risk of conviction. And it's occurred specifically within the age ranges of around 16 to about 23. Now here you start to see a similarity, a kind of qualitative similarity, is in terms of once around about the age, the year of 2005 was reached, there's been this kind of nosedive of age-specific conviction rates. Another slightly more subtle way of looking at and of slicing the data is by birth cohort. So this is a equivalent of taking a lot of diagonal slices through the Lexus surface. These diagonals determined by 1 year per year. So they're diagonals moving at 1 year per year, taking a lot of sections, lot of parallel diagonal sections for the birth cohort born in 1960 up to 1985. Now again, this on the face of it looks relatively similar to the age crime curve. However, there are some somewhat more subtle patterns revealed by looking at particular birth cohorts. In particular, and this wasn't anywhere near as apparent or even not apparent at all when you just looked at ages alone, you can see that there are a number of birth cohorts that, as they reach their 30s, the decline in conviction rate that might be expected stalled somewhat. So you can see these kind of horizontal stretches in these graphs for the cohorts, the birth cohorts beginning with approximately 1963 up to perhaps around 1970 or thereabouts. You can see for these birth cohorts there is a kind of stalling in the decline of the conviction rate from about the age of 32, 33, 34 up to about the age of 40. So there was a kind of holding back of the age-based decline in the conviction rate that might be expected. So this is evidence of a kind of cohort effect, or it may be evidence of a kind of cohort effect. Something about these birth cohorts and the conditions they faced, perhaps when they were in their 30s and so on, meant that they still kept being convicted at a higher rate than might be expected given their age, and that has been observed in other people of the same age range but from other birth cohorts. So in conclusion, we're thinking about the factors that influence the change in conviction rates over different ages, years, groups, genders, and cohorts. We can say that there is broadly a kind of hierarchy of factors, a hierarchy of kind of explanatory variables that go to help to characterize the likely conviction rate of different types of people. Of this, the most important factor at the top of the hierarchy is gender. So now, using the contour maps and the fact that they're labelled, we can work out, for instance, that the peak female conviction rate is equivalent to the male conviction rate in middle age. However, once we've accounted for gender, the next most important factor in explaining the change in conviction rate is age. Following from that, period matters. And this is the main interesting thing that's happened in the last few years with mortality, with conviction rates in Scotland, in that these age-related conviction rates have changed and declined very sharply for many age groups within the last few years. The least important, but still quite significant factor which can help to explain or predict conviction rates is still cohorts. So there is still something, once you've accounted for gender, age and period, there is still something that cohort effects can still account for.